All right, so this mini tutorial is going to be about kind of setting up a federate and what that takes and the different stages of configuring and getting a federate up and running. So just a bit of a review of some terminology we use in Helix. A federate, this is basically an individual simulator that does something interesting. So it's an individual execution block, and it can communicate and interact with other federates throughout the Federation. A core is an object that manages one or more of these federates, so federates talk with cores. A broker is a coordinating object. It's internal to Helix, and it coordinates multiple cores or brokers, and there can be several layers of these brokers in a hierarchical fashion. The root broker is the top-level broker in the hierarchy, and its purpose is to be a last chance router, so any information that is not routed in the sub-brokers or the cores ends up routing through the root broker. And it's also responsible for determining when to enter the initialization mode in the Federation. And we'll go over what that involves in a few minutes. The Federation is the set of all these federates, cores, brokers, basically everything together that forms a single co-simulation. Graphically, you can kind of see what this looks like. The intention is to have Helix work across multiple machines and multiple different systems. So you can have the root broker working on one system, the sub-brokers work on others or the same system, and then each broker is responsible for one or more cores, and each core can be managing one or more federates. And these can all be on different or the same machines. There's a couple different types of federates throughout Helix. The first is a value federate, and this establishes direct fixed communications to other federates. This is meant to simulate physical values being passed back and forth. So if you have, say, voltages from a transmission network going to a distribution network, and these interact together in a pretty fixed fashion, this is where you would use the value federate. And they also have associated types and units, so you can send different types back and forth or different kinds of data, and they can have associated units with them, so you could do a unit translation. Message federates, on the other hand, send packets of data, so there's no fixed connections. If you establish a endpoint in a message federate, which is the kind of the communication interface, it can send data to any other endpoint in the system, and it can receive data from any other endpoint in the system. So there's no fixed connections that are established during the initialization steps. And this can be used for such things as events, kind of communication packets, simulating network traffic, triggers, or other things that are kind of discrete events that go on in a co-simulation. The combination federate is as it sounds, a combination of both different types of federates, so it can do value interfaces and message interfaces in the same federates. Filters are another concept that have been added to Helix, and they are available in any federate type, so they can be added to value federates or message federates, but they mainly interact with endpoints. So they can modify messages coming from or going to specific endpoints. So this can be used for things such as delaying a message going out, so time delays, accounting for propagation delays. You can randomly drop packets. You can clone messages. So if you wanted to spy on communications, you could do that. They can do message translation. So if the messages coming out of one federate are not able to be understood by another, you can create a message translation filter that translates the information from one format to another and then translates it back on the other end. And this can also be used for rerouting. And this can be useful if you want to establish a communication network in place between two other federates. And so then this way you can seamlessly insert different things inside a federation and not have to worry about making sure all the connectivity from the original federates are in place, and they don't have to be aware of the different filters that are going on. The different states of as you go through the lifespan of a federate, it goes through kind of 4 different states with an additional state for errors. So basically, you create the federate, you establish communications and figure out what its interfaces are. Then you initialize it. In this place, in this state, you can establish some initial values and pass some information back and forth that sets up the federate to start executing in time. And then the execution state is the main loop where it moves forward in time through the whole federation. And then there's a termination state at the end to finalize things and finish them out. What this looks like as far as the life cycle of a federation when you're actually working on it in code and actually setting it up, you start with creation. You're actually building the federate. You set up the different interfaces to it. You initialize the federate. Then you move to execution and finally go through finalization. And what we're going to do in the next couple of minutes is to kind of walk through a few things of what that looks like in a very simple example. So in creation, you can create a federate using a number of different core types. This establishes which communication protocols the federate uses and how it can interact with others. So the test core is the one we use for testing, but it can also be used for in-process sharing of information. So if all your federates are in a single process in a computer, you can use the test core, and that's probably going to be the fastest way to do it. The IPC core uses boost interprocess queues, and this can be used for communication on a shared memory system, and it does not support sub-brokers. The 0MQ is our primary one we use as the default. It uses the 0MQ messaging protocol for communications. We also have UDP and TCP streams and packets that can also be used if you don't have ZMQ on a particular system or platform. And the MPI, the message passing interface, is an in-development communication system, but this was what will be used on high-performance computing systems. We have created a Hello World example, and you see the website there. But the code on the screen, we're going to kind of walk through it a little bit, and this is using the C interface. So typically, you create a federate info object, and this is passed configuration information, and you see some calls to do that on the screen. And then you pass that into the constructor or the creation function, and this sets up the federate using that information. Once you have a federate created, you can create the interface. And this is the setup phase where you establish which interfaces a federate uses. And there's API calls for this, and there's also file readers that can interpret a configuration file and set up all these interfaces for you. To enter the initialization stage, you call the enter initialization mode function. And this is a globally blocking function and will not return until the entire federation is ready to enter the initialization phase. And in this phase, you can send some initial communication, set initial values, and respond to it. The enter execution phase is where is the transition from the initialization to the execution phase. And this can be done iteratively if you need to establish iterative communications between different federates to converge to a consistent value. The execution phase, you're basically sending data, sending messages, publishing, receiving, and requesting time. So in this case, this sends a hello world message and requests the time of 1.0 as the next time. And to finalize a federate, you can call the finalize function, and then in the case of the C library, you should free the memory allocated to the federate and then close out the federate library. And that is the mini tutorial on setting up a federate and a quick example. So if there's any questions, we'll answer them. Otherwise, we'll move over to Deepak, and he can show you about the Python interface.
So Phil, this is Trevor at PNNL. You said the value federates, their routing is defined at the federation creation time or runtime or initialization, but the message federates are not?
Yes.
Is there, do you know if there's a performance difference or an expected performance difference due to that?
I don't know what that will be. I would expect there to be a little bit. There are some API calls that can mitigate it if you actually know the communication paths ahead of time. But for small federations, I wouldn't expect it to have much of an impact at all.
Are there any other questions for Phil? All right, otherwise we'll switch here to the other recording. Give us just a second to get set up here.